Today is day 6 of Nodevember, which means we're 20% through. Let's give a round of applause for that. So the prompt for today is lake. So I'm actually making a bouncing basketball, and you're thinking, what does that have to do with lake? Well, there's a team called the Lakers, and that's about as far as the connection goes. So in geometry nodes, make a geonodes object. I'm actually going to start with an icosphere. Why am I doing that? Well, as we increase the subdivisions, you can see 1, it's becoming a sphere, but 2, you can see that the geometry is actually very well distributed, and having all this extra geometry is going to be super useful for kind of cutting out these lines in the basketball. To do this, I'm going to make the cutting plane. So this is the first plane. I'm going to make it bigger, make a duplicate of this that is rotated, and I can join these. And then the rest of these cuts are kind of like these paraboloids. Well, with a grid, I'm going to increase the number of divisions because I want to distort this. And I want to turn it into kind of a parabola shape or almost like a saddle on 2 axes. And I care about the X and the Y axis as parameters. And looking at the X component, we can map range. Because it goes from negative 1.5 to 1.5, we're going to want to change that. So make this negative 1.5 to 1.5. Use this to distort the Z coordinate since I want this to distort vertically, and this is what we're going to use for the offset. So you can see immediately we get this line because we increase as we go on the x-axis. I'm going to use RGB curves, bring this down, and then kind of like draw what I want from this. And it kind of needs to be flipped. Easy way to do that is I just make it a negative. So I'm going to multiply by -1. Take this plane, join it with the other planes. I'm going to make sure to also transform this up by some amount. Can't tell you exactly how much. And I'm going to make another copy, making sure to use the previous transform, which is going to be useful because when we rotate on the y-axis by, let's say, 180 degrees, you can see it keeps the same amount of separation. And like I said, this should also be having curvature on the y-axis. So we're pretty much going to use the identical setup here. And then we add these components together. So long story short, we have all our grids, we have our icosphere, and we want to cut one from the other. To set position on the icosphere so that I can change it around. And I actually want to offset it by the normal coordinates, but we're going to do this backwards so it eats into the sphere instead of popping outwards. And then for how much we're going to do this, we're just going to use geometry proximity. It's basically going to be useful for making a mask. So vector math, we are going to scale the normal by this distance coordinate, which you can see kind of creates this, would you call it a basketball? I think it's actually getting closer to a football. Either way, we need to map range this obviously, play around with these numbers until we get kind of like the cutout of a basketball, so something like that. And I'm going to decrease the size of this until we're getting like tiny little cutouts. I'm going to actually use smooth step to make it not as intense. And one thing I'm seeing is, yes, we're getting our cuts, but the distortion totally isn't right. So we're going to need to play around with some numbers. And as I was playing with this, I found that just changing the map range for, I guess, the x-axis kind of gave us a better looking shape. I think it needs to be kind of like higher curvature. Easy enough. I'm just going to kind of move these little numbers inwards a little. And for our grid, I'm just going to increase the number of, resolution steps. And there we go. I think that's looking kind of close to a basketball. Basketball nerds, let me know if this is accurate or not. Maybe the first thing I can do is actually set shade smooth. That might be enough. You know what? I could argue that that's enough smoothing. And then instead of like extruding outwards onto normal, we can do what we said we do and actually just go negative a tiny bit. So we are going to set material right here. We're going to, I know you can't hear it, but this leaf blower outside is messing with my brain. Call this the material. I'm going to rename this to basketball, go to rendered view and just kind of like set up our scene with cycles. I'm just going to add a sky texture, which isn't ideal because basketballs are usually inside, but we're going to have to make do. Increase the sun size to get a softer shadow. I'm also going to increase the altitude and maybe mess with the sun elevation. Now, to get this to look like a basketball, I think the first thing we can do is just kind of pick a color that looks correct and use this for both of these. And we're not going to know what this looks like until it's in reference to the BSDF. It's looking very low resolution, which I thought we could get away with, but maybe we can just add one more division. Okay, first order of business is these like interior lines should be black, and that just isn't like shadow, it's actually a different color. So to isolate this, instead of using like an attribute, we can be a bit lazy. We're going to use texture coordinates and look at the object coordinate. If we take vector math and set this to length, what you're going to see just barely, if not at all, is the length is going to give us like how outwards in terms of the radius is each point on this and exploit that. So with the map range, I'm just going to bring up our bottom until you can kind of see that this is poking through, and this is going to be our mixing factor where the bottom is going to be black. Next thing which makes this look like a basketball, actually this is the main thing, is kind of like the ribbing here where you have a bunch of circles. There's a bunch of ways to do this. Probably the most accurate way actually is to use the geometry. I guess probably a lower resolution one where each one of these points is a circle. You know what? Let's do it. So I'm going to take 6 divisions and we're going to compare the high res to the low res, geometry proximity, to this mesh, but this time we're going to look at the points and I can store this attribute. What we need to do is we need to set position, and we are going to do that again based on the normal. This time we're going to change our scaling a bit. This might get very choppy in a second. We'll see. So I'm going to plug this into the offset. Okay, that isn't too bad. I believe I want to invert this. I think the ribbing goes outwards. So I'm going to make it 1 to 0. Clearly that was too much. So instead of 1 to 0, maybe like 0.1, something that isn't too intense. And I want to up the contrast. First of all, level this off so that there's nothing going on. I'm going to add a peak right here. But the difference is this time I kind of want to flatten it a little. So maybe I can use these like linear handles and kind of bring this up so there's kind of like a flat section. I'm going to take this and make it way less intense so it's not as crazy. Okay, I'm happy happy with this. The only thing we need to fix is that this should not be happening inside the line. So if we multiply this again, remember if this is 0, nothing's going to happen. And I think I'm going to take the simple approach where I'm going to take this distance and make a harsh cutoff with a greater than, because I don't think there would be like soft dots here. We're going to connect this here. We're going to really lower this greater than, which you can see gets closer and closer. This is actually a pretty cool way to make a mask in itself. Maybe we'll utilize this. So divide by 2, it's getting closer, divide by 2 again. And just like that, we have our geometry without doing too much shading magic. I mean, it kind of came by itself. I think it's slightly too shiny, or maybe we can make it rougher and then add a bit of a clear coat, which is kind of like a shiny lining. I really don't know how basketballs are made, so I cannot tell you if this is accurate. And we can tint this a little to kind of work for us to kind of be basketball colored. And you could argue that maybe this like black right here needs to kind of be a higher roughness so we can see the color, in which case this should be easy to do. Remember, we have our like factor here, which I guess we can't see because we're going from 0 to 0. So where this is black, I want to bring this up to like 0.5, and then otherwise maybe it should be a bit shinier or not. I'm not really sure. Connect that to the roughness. Now at this point, we can call this basketball done and start doing our physics, but I want to add a little something extra. You know how every basketball is just covered in fucking logos to try to sell more? I want to map some text onto here, where if you saw the 4th video in the series, day 4 of Nodevember, we made text on a scroll, and we can kind of use the exact same method here. So what I'm going to do is I'm going to create some text, or actually I want it to say nodes. So I'm going to make sure to center this and pick a font that kind of reminds me of basketball. So I'm going to realize the instances, and then I'm also, let's think, I think I want to resample the curves to kind of make this higher resolution. This is the same thing we did last time. And I want to map this text on the curvature of the ball. Do some ray casting, I guess. I'm just going to make another sphere so it's not as like computationally expensive. This is going to be the same size as our basketball. And with this text, I'm just going to project it down onto the sphere. We can ray cast onto our sphere, again, going -z direction. And then we just set position, very simply, position it at the hit position, which mapped it onto our sphere, but we're getting kind of like our distortion here. And to me, that indicates that there's some text that didn't actually hit on a ray cast, which is expected because it's probably too big. So I'm just going to bring down the size of the text. And at this point, you can kind of just pick where you want this to have the text, right? Because this is on a sphere, we can make a very easy transformation where we can just like rotate, you know, transform geometry. We can just kind of like rotate this. And I'm just going to move it downwards a little so that it's on our like section right here. And again, we're not going to keep this actual geometry. We're going to use this to map an attribute that we're going to use in the shading. So this time we want a store named attribute, I guess before the material, although I'm not sure if that matters. I'm going to store a float that I'm going to call distance. And just like we've been doing every single time, I'm going to use geometry proximity, and we are going to look at where the nearest, I guess, point, edge, or face. Let's start with edge and see what that looks like. So we're going to store that here. So I'm going to curve to mesh to actually make this a mesh object. And you can see we get our nice parameter here. So in the shading, what we should be able to do is bring in this attribute, and we'll just kind of use it as a mask. So I'm going to make this a bit higher contrast. So we're pretty much only getting the text. And I don't like that this is only the outline. I think it would look a lot crisper and better if, you know, this was filled in here. And to do that, what I need to do is instead of edges, I need to do geometry proximity from the faces, which isn't going to work because there are no faces, is after we resample the curve, I believe we can just fill the curve, which is going to do our distortion. And actually, it looks pretty cool with these dots. So I'm going to mix again using this as the mixing factor, where this is actually going to be the second socket. And here you can see black, bit of a addition to offset our color ramp. So we're just going to make it a bit negative. So this is before and after. So another trick to make this more visible is we can use just a tiny bit of normal mapping, because I guess the text would have a tiny bit of thickness. By using a bump node, we're going to use our map right here, putting it into the height socket, putting the normal into the normal. And to make that less intense, I'm just going to bring down the strength. So this is without and this is with. I'm going to take desperate measures because, you know, that's what we're going to do. We're just going to mix this with a diffuse BSDF. Either way, I'm just going to use this color ramp here, which is going to let us bring down the color of one of these. I believe I just switched them. And now if I make this closer to black and also increase the roughness, we can use our normal map again. So I think final thing I'm going to do, I know I keep making modifications, I'm just going to make this text a tiny bit smaller so it fits the ball a bit better. And you could play around with the font. It's all procedural at this point. And again, one more thing, I think something that will make this look cool and kind of more defined and intentional is if we kind of make an outline around this text that maybe is a different color, like yellow or something like that, we can make a duplicate of this. And for this version, I'm going to make it constant, which is going to make it super like high resolution, or super crisp is what I mean. Mixing before our text using this as the factor. And I could just put like a different color. So let's try green just to make sure that it works. So yeah, you can see now we have our, you know, thing going on here. I'm going to make it more of a basketball color, like yellow or red or something like that. Okay, at this point, I'm calling our basketball done. This was the hard part of the tutorial. So in GeoNodes, just take literally everything, Control G, and now this is a single node. Obviously, basketball has a very, or blue, a blue vibe. So I'm going to go with that. And the last thing we need to do is just our basic physics where it's going to bounce. There's a single point defined in a box that goes from like 0 to 1 on the X and the Z axis. And we have to give it gravity and have it bounce around and stuff like that. So I'm going to make a point right here, move it to 0.5 on the X and 0.5 on the Z. You've pretty much seen this in the last tutorial with the fluid, but now it's literally a single point. I'm going to move its position on every single frame by how much? By velocity. What is the velocity? We need to define it. Velocity is going to be equal to itself, but we are going to add a bit of an acceleration. This is going to be the gravity. So we are just going to vector math, add this right here. Finally, what is acceleration? We define it right here and make it a little bit negative. So when we play this, you can see things are falling. I'm going to make it less fast, slower might be a word for it. If it goes on the ground, its velocity is inverted. If it goes on the sides, its velocity is, I guess, reflected on the x-axis. Look at the position because I want to check where the z component is less than 0. In other words, it's beneath the floor. And in that case, we're going to take our velocity and we are going to assign it to itself. But the only difference is now we are going to take it and invert the z component. So x is still equal to 1. So make sure to add this condition. And now we have a bouncing ball. We haven't really said for this particle to stay within the bounds. It does reflect, but what happens if it kind of goes a little bit through? Then it's kind of stuck under here forever. We are also going to set the position to the position, except this time we are going to multiply the z component by 0. In other words, get on the floor pretty much and apply this conditional. So now when we play this, you can see it's working. And you can see it's now bouncing and pretty much conserving its velocity, which we can make that not happen by reflecting this not by -1, but by like -0.9. So it loses 10% of energy. So now you can see it's kind of like the bounces are getting shorter. But this point is the same thing, but for the x-axis. So we're going to define the velocity. Take our velocity and in this case reflect using that 0.9, our x component, connect that to the value. All we need to do is check if it has exited the 0 to 1 wall. Well, we look at the x component and see if it is equal to 0.5. The reason it's 0.5 is this is halfway in between here with an epsilon of 0.5, which is basically a fancy way of saying check if this is between 0 and 1, because we're seeing if it's equal to 0.5 with 0.5% of error. When this is not equal to this, in other words, it's outside the bounds, then we want to do this right here. And just like before where we had to set position to make sure that it stays within the confines, we're going to have to do that again for the x-axis. Under our conditional, take the position, and for this one, we can define it using maximums and minimums of 1, 0, 0, so it can't go beneath the floor or like from this side. It's going to take the maximum of 0, and this should be 0, 0, 0, right? And I guess we want the z to be within 0 to 1, so we're going to make that the minimum. So let's test if this works. It does. Only thing I want to add is I want to kind of bounce this on the side, so I'm going to give this a initial velocity before we even enter our simulation zone of a bit of a x component. So now it's going to launch off to the side, and clearly we made a mistake. And that mistake is I think we used the wrong conditional. So we were using z instead of x. Okay, I found the issue. So when we update the velocity on a x collision, we need to maintain its vertical component. So now, yep, it bounces and it's losing like energy and stuff like that. Last thing I want to do is you can see that at a certain point it just kind of like slides around, but it's not losing any energy due to friction. And maybe an easy way to do this is we look at our velocity update, where again, we take its velocity and add some acceleration. We take this and we scale it by 0.98, so it's losing 2% energy on every frame. So now let's actually see what this does. Yeah, you can see it slows down. And I think that's fine. Maybe what we can do is we can have it be 0.98, or if it's on the floor, it could be even bigger. So now we have like friction due to contact instead of air resistance. So we could have it be 0.98 and then like 0.95, so really kill its velocity. So we are looking at the z component, and I want to check if this is less than or equal to, well, you can say 0, but it might always be slightly above. So I'm going to do like 0.05. Okay, it's doing it, and it's losing a lot of momentum quite quickly when it's on the floor. Okay, so we have our particle physics. It's pretty much that simple. All we need to do is at the end, we say, don't make this a point, but instead instance our basketball, which clearly is too big, and that is working. Now you could argue that this is like incorrect because it's dipping below the z-axis, and that's because this has a radius bigger than like 0.01, which the point had. But honestly, that's fine. You can just imagine the bounding box is a bit bigger than we imagined. Okay, so last thing you're noticing probably that makes this look weird is it doesn't have any sense of rotation. Now, the way I used to do this is I would take a random vector, and I would kind of take the simple approach where I scale this, and I do that over time. It's a little bit wrong. So I take time, make it like 4 times slower, and you can see our ball is now rotating, but it doesn't lose any rotation when it's on the floor, which it should. So we almost want to do the same thing we did before. I'm going to make another attribute. This is going to be ROT for rotation in a random direction going from -1 to 1, and to make sure that it's normalized, and we only care about the direction, add a normalize. Now, instead of this random vector, we can use our now defined rotation, plug this into rotation, and now it's basically going to do the same thing, right? It still doesn't kill any momentum. So what I want to do is I want to take its like rotational velocity, kind of like kill it over time. So similarly to velocity, I'm going to define the rotation as equal to itself, but what I'm going to do is I'm going to scale it, in other words, weaken it by, let's say, again, like 2%. And to say that it needs to be on the floor, what I can say is we're going to use this conditional to mix, well, I guess we want a mix just factor, 1 and 0.98. So in other words, when it's not on the floor, it's going to maintain its rotation, and otherwise it's going to kill like 2%. So let's see what that looks like. So it's rotating, and then does it ever slow slowdown. Let's try to like make this thing a bit more intense to see if that works. And there we go. Okay, so it works. Rotating too much from the get-go, and that's easy to fix. I just take this normalize, and then I scale it by, let's say, like an additional 0.5, so it doesn't go as fast. And then the rest of this is basically like picking render settings. But you can see that especially in motion, this is going to look super real, and we have our like text and all of that. And let's see what this looks like with motion blur. With motion blur, I don't know. To me, it just kind of looks real. And now, yeah, I mean, it's hard to make things not look real when there's like motion blur. So there you go. That's day 6 of Nodevember. The prompt for tomorrow is chaotic. Who knows what we're going to do for that? The world is our oyster. Tutorial over. Let's get rid of our tutorial candle. And with that, make sure to join the Patreon to get access to the 1 file and 30 files that I upload this month. There really isn't a better deal out there. File in the description. See you tomorrow.